Day 2 of pre-calculus. This is piecewise functions. Like a movie, you know, like. Okay, anyway, I was envisioning something. Okay. I'm gonna put it up against the thing. I hope you can see that. Don't slide. All right. So anyway, this is piecewise functions. So with piecewise functions, guys, I want you to copy down this function. All right. So this is f of x, and it might look like, oh my gosh, I have 3 functions. Well, that's why it's called piecewise functions. A piecewise function is a function with multiple components. All right? So it might look like something on this end, but it might look like something else on this end, right? It's like a mutant function, right? Okay? And we're going to see what it looks like. Okay? So this is a function with multiple components, and we're also going to learn what in the world this is right here. All right? So the way that I read this is f of x is equal to 3x plus 2 if x is less than negative 2, x squared minus 3 if x is in between negative 2 and positive 3, and the square root of x minus 3 if x is greater than or equal to 3. All right? So that's 3 different functions. We learned yesterday the names of these. This is a linear, right? What's my second one? Quadratic. And my last one? Square root function, radical function. And we learned the transformations, so we should know roughly what these look like. Okay? So, your objective is very simple. To be able to graph them. You need to be able to graph them. Okay? So, how do I graph it? Well, it would be a problem if I would, if I would graph all 3 on the, on the coordinate plane, all together, because you would have a lot of overlap, right? And if you have overlapping functions, well, you don't really have a function because it'll fail the vertical line test. For example, and this does not pertain to this problem, but if I had a parabola and then I had a line, that's a problem. That's not a function, right? For example, this input, it has 2 separate outputs, 2 distinct outputs. So it's not a function. So that's why it's so important to know how to graph these correctly. Okay? So I'm going to show you how to graph it correctly so that it passes the vertical line test. All right? We're going to start with the first component, 3x plus 2. We all know what 3x plus 2 looks like, right? It's a function that has a y-intercept where? At 2. Okay? And it has a slope of 3 over 1, right? So, más o menos, it looks like this, right? Make sure you're using pencil, by the way. You're going to have to erase some things. All right? Now, that's 3x plus 2, and that's fine. I mentioned we're not going to graph it across the whole coordinate plane, though. All right? Does anybody know what part of this I'm going to graph? Dakota?
You're going to stop where x is negative 2.
I'm going to stop exactly at x equals negative 2. So, guys, what I'm saying with this is that this specifies your domain. All right? Think of your domain as where. And think of your functions as what. This is what I'm going to graph, and this is where I'm going to graph it. I'm not going to graph it across the whole plane. I'm only going to graph it where my domain specifies. So, this function will exist only when x is less than negative 2. So what I will do is I will go to negative 2, and this is a very rough sketch, right? I will go to negative 2, and let's think, what's my output at negative 2 for this function? Let's see, 3 times negative 2 gives me? Negative 6. Negative 6 plus 2? Negative 4. So the point is 2, negative 4. Right here. So actually, I'm only drawing this part of the function. You should only have this bottom part of the function. And I know it doesn't exactly seem like it lines up, but that's human error right there. All right? So this is 3x plus 2, but you only drew the bottom part. And actually,